Now, if statements are a very important part of programming and C++ programming, because an if statement, I want you to think of it as a way for a computer to make a decision based on certain conditions being met. Meaning, if you think about like a small weather app, there might be an if statement that says, if it is raining, then show a cloud on screen. But if it is sunny, then show the sun on screen. And that's kind of what an if statement is. It says, if this is true, then do this. And I want to show you that. I'm going to say if, and we're just going to put true in here, which is a Boolean variable. And we're going to go over that here in a second as well. We're going to say, this code is ran. Okay? Let's actually add an end line. And when we run this, it'll say this code is ran because the condition inside these parentheses is true. And inside these parentheses is where you put your condition. So if we put false, okay, this code will not be ran. When we run it, you will not see this. It will just return 0. And just kind of show you, to kind of touch more on true and false, if you remember in one of the first tutorials over data types, we talked about Boolean data. And to do that, you type bool, because we're going to declare a Boolean data type. I don't think we actually did an example of Boolean data type, but I think we did discuss it maybe. And I'd actually have to check and look. But Boolean data is another data type that is either true or false. So we could say Boolean, var1 equals true, and bool var2 equals false. And then we could actually put the variable in here, so we could say bool var1, and which is holding the value true. And this code will be ran. If we run it, this code is ran, as you can see. So you can kind of see in this tutorial, along with if statements, we're also kind of learning about Boolean variables, which are a very important part of C++ programming as well, because all of these if statements are going to be focused on whether the condition inside these parentheses is true or false. Now, that being said, you don't have to have Boolean data in here necessarily. We could actually do something like this. We could do int num1 equals 5, and we can say if 5 is greater than 3, then run this code. And this is the greater than sign. And if we do that, it'll say this code is ran. Because, and actually I hard-coded 5 in here, but you could actually put num1 as well. If num1 is greater than 3, and it'll say this code is ran. Same token though, if 5 is less than 3, which it's not, then this condition is false, because 5 is not less than 3. That returns false, so this code will not be ran. If we run it, you can see process returns 0. This output statement was not ran. So that's pretty simple stuff. You can kind of make an if statement run based off of whether the condition inside here is true or false. And we're going to go more in depth with that later in this section when we make our own app, practical app that you could use. And I might even make some kind of number guessing game. I haven't decided yet. But either way, we're going to really show how we can use these if statements to make really nice flowing code that makes decisions based on user input. So that being said, what if we wanted to add another part of this if statement, basically saying, if num1 is less than 3, we'll say, we'll actually say that, we'll say num1 is less than 3. But what if we want to say if num1 is greater than 3, we'll say num1 is greater than 3. Well, to do that, we put else if num1 is greater than 3, brackets, output, num1 is greater than 3, end line. And to make it more interesting, we're going to say int num1, and we're going to say enter a number, and then put that number in num1, and then depending on that will be what code is ran. So you can say when we enter a number, it's going to hold it in num1, okay? And if num1 is less than 3, this code is going to run. But else if num1 is greater than 3, then this code is going to run. Watch when we run it what happens. Enter a number. We're going to say 7. 7 is greater than 3, so this code down here should run, but this code right here should not. And when we hit enter, it says num1 is greater than 3, and only this code ran. And so to run multiple if statements together based on one calculation, kind of, you would use if and then else if. And then if you wanted to basically do a default, if all the above are false, you add else, and then brackets, and then you don't add a condition to an else statement. This basically says if all else fails, if all these return false, then do this no matter what. So just kind of thinking about it, what would be the default? We could say, you know, if num1 is less than 3, do this. If num1 is greater than 3, do this. Well, otherwise, that would mean that num1 is equal to 3, right? So we could say else num1 is equal to 3. And to show you that, we'll run it, and we'll enter 3. I'll say num1 is equal to 3, because basically we didn't even have to do a condition, because it knows. It says, well, the way we did it, the way we coded it, we said if this is false and this is false, then do this. You know, if all else fails, do this. And that's what happened. But at that same token, you really don't even need this else statement. If you just wanted to do another else if, you could say else if num1 equals, and just to, this may seem confusing to you at first, but in an if statement, when checking if something is equal, you do need 2 equal signs. This may seem confusing at first, but it'll probably take a little bit of practice, but that's just how C++ and even Java is coded. You know, you do need 2 equal signs to check a condition inside an if statement. So that's why I have 2 equal signs here rather than just 1, because that will actually return an error. So we need 2 equal signs here. So basically it's saying if num1 is less than 3, do this. Else, if num1 is greater than 3, do all this. Else, if num1 is equal to 3, then say num1 is equal to 3. And that's the same thing as just saying else, do this, because those are really the only 3 possible outcomes. But you can see if you had a whole bunch of different statements, how you might just want an else statement at the end to return a default value, such as, you know, for instance, there's really not anything that would run this code. So you would say you didn't enter a number, you know, because that's probably what would happen. In fact, I think if we entered a string, it would actually return 0. It would just throw 0 or a garbage value in num1. So let's see. Let's just run it real quick. If we enter 3 again, this code will run num1 is equal to 3. But let's see if we don't enter. If we enter something, let's see if we can try to get this code to run. Such as if we run, just type in star or something. It'll say num1 is less than 3. And the reason why it's saying num1 is less than 3 is because, even though we entered star, is because num1 is a garbage value right now. Because we entered star, and we're supposed to have an integer value inside num1, so instead it threw a garbage value in there. which is probably actually 0. It probably just defaulted to 0. And we can actually check at the end of everything. We can actually output after all these if statements num1. So if we type in something like Zach says num1 is less than 3, and the reason why is because the default value for num1 just happened to be 0. That was the value in the memory address for num1, and that's why. So you can see how important it is that the user enters a number, because if he enters a string, then the first branch of code is going to get ran. This branch right here, which may not be what you want to happen. So it may be a good idea in a program like this to put emphasis on number. There's obviously other ways you could handle it other than just putting emphasis on that. For instance, there's try and catch pieces of code, but that's all advanced stuff again, so we won't be worrying about that. But when you get into more advanced programming, you will be doing try and catch clauses and stuff like that, and catching your exceptions that get thrown for whenever the user enters wrong data. So that being said, that's pretty much all there is to if statements. I do think it's a good idea for you to maybe go look up the operators that you can do. For instance, if num1 is greater than, you can also do greater than equal, which means greater than or equal to 3. You can also do less than or equal, which basically if num1 is less than or equal to 3, it will say num1 is less than 3. If num1 is greater than or equal to 3, num1 is greater than 3. And let's just run that and see if both codes get ran, because basically if we enter 3, it'll say num1 is less than 3, because only this code got ran, but really it could have ran if we just had if instead of else if. Because if I put an else if, it's basically adding it on to these if statements. If we enter 3 again, I think all 3 of these will actually get ran. Let's check it real quick. I believe I believe it's actually froze, but I want you to play around with it right now, and just kind of look at all the different operators again. Another good one to look at is not equal to, exclamation point equal. That means not equal to. So if it says if num1 is not equal to 3, run this code. Now, I'm going to go ahead and kind of give you an example of what a switch statement looks like, and then discuss to you how it works. So, going to go ahead and type out everything. Right here is where the switch statement starts. Okay. Oops. You put everything in brackets. Go ahead and give you some room. And then you put your cases in. So here is our switch statement, the basic functionality of a switch statement. Okay, and I typed it out because I just kind of want you to follow along. It's going to be easier for me to explain it to you like this. So here we have a variable called grade, and our grade is a B, okay? And then below that we have our switch statement defined in these brackets right here, everything in these brackets, okay? So basically, to define a switch statement, you write the word switch, and then in parentheses next to it, you put the variable that you are analyzing. In this case, it's grade. So we put grade here. And then, in your brackets, you put your cases. So you put case, and then what you're comparing the grade to. In this case, we're comparing it to different letter grades. So the first one is case A. And here, you enter more brackets, and you put the code that you want for case A. So, you made a 90 or above.
And then on case B, you do the same thing. You can put your code here. You made a 80 or above. And you can repeat that for each of these, and I'm going to go ahead and do it here so that you get full visualization of how the switch statement works. Then case F, you failed. So basically what's happening here is this code runs, we have a grade of a B, and then we look in the switch statement, we tell the switch statement to analyze grade, which is a B, so right here is grade, the variable that we're analyzing, and we say, is it an A? Well, no, it's not. Is it a B? Well, yes, it is. So we're going to run this code. Is it a C? Well, no, it's not. Is it an F? Well, no, it's not. So this is the only code that should get ran. But I want to show you something real quick so that you can see what happens before I fix it. Let's go ahead and run this program. And you can see it says you made an 80 or above, you made a 70 or above, you failed. Well, that's interesting because we made a B, it said everything except A. But once it got to B, it basically did all the code below B. And that's because in a switch statement, you need to add a break. And to do that, after all your code, you say break. And you do that at the end of each case to tell it to leave the switch statement. Because switch statements have what I like to call a waterfall effect. Meaning if you don't put your break in right here on this code to break from this switch statement, then once this is true, it's going to waterfall down into the rest of the code, the rest of the switch statement code. So if we took out this break statement right here, it should run the B code and then run the C code before it breaks. And let's check it out. As you can see, it said you made an 80 or above, you made a 70 or above because it didn't break from the switch statement until it got right here. So what we need to change is, of course, if we just add a break here, you'll see that it says you made an 80 or above because our grade is a B. And just to kind of show you how we can further this, let's do grade, and then we'll say something like enter a grade, enter a letter grade, okay? And then let's use CN to hold our grade. And then let's watch how this switch statement is used. So enter a letter grade. We're going to enter F. It says you failed because basically it went through the switch statement. It put the grade that we entered in here in the switch statement, analyzed it, looked for the case. Is it an A? No. Is it a B? No. Is it a C? No. Is it an F? Yes. You failed. And that's how a switch statement works, okay? So let's run it one more time. We're going to enter in, let's enter in an A. It says you made a 90 or above. So that's the basic functionality of a switch statement. And you can see how it's very similar to an if statement by checking which condition is met. And like an else statement in an if statement, a switch statement also has something similar to else, which is called default. So if we wanted to take out this F, we can just say default you made an, or you failed, which is the same thing as saying is if none of these are true, then obviously he failed. Let's go to the default switch statement, which is he failed. If we run that and we enter in an F, or let's even enter in a D, it'll say you failed, because if we enter in a D, obviously A, B, and C aren't a D, so it's going to go to the default and just say you failed. But you know, obviously if I enter a Z, that same code is going to run because it's neither A, B, or C. So if you wanted to restrict the user to only entering the correct letter grades, what you would probably want to do is say something along the lines of case F and then output you failed in line. And then on the default, you could say something like you entered an invalid letter grade. And now when you run the code, if it's not A, B, C, or F, if you enter something like R, it'll say you entered an invalid letter grade because it's going to the default.